Mars is 140 million miles away from Earth. Have you ever wondered how we might know that? Actually, scientists knew this in 1672. How did we know this 353 years ago? Well, the answer is parallax. Parallax is the difference in appearance or position of an object when viewed from two different locations. For example, hold your pointer finger out in arm's length distance from yourself. First look at it from your left eye and then from your right. As you might notice, even though you didn't move your finger might appear to shift position compared to its background. This is a simple example of parallax. Parallax can be used in astronomy, just like how it was used to see how far away we are from Mars. This is a simple guide to understanding parallax and how to calculate it yourself.
In astronomy, this is how to calculate parallax. First, take two pictures of a region, like an area of a galaxy, 6 months apart. These, for example, are two photographs of the star WHG64. But why do we take these photos 6 months apart? The reason is because on Earth, 1 year is one rotation around the Sun. Therefore, 6 months is half a rotation, giving us a distance of 1 astronomical unit from Earth's location to the Sun. As on the diagram, Earth's position and Earth's position in 6 months acts as two different locations that allow parallax to occur. Second, compare the positions of the star and measure the shift. Basically, measure the distance between where the star was in its first picture to where it is in the second. You can see this outlined in red in the second photo. The closer an object is, the bigger the shift. Third, use a scale to calculate the shift in arc seconds. In step 2, we calculated the distance between the star's location on a photograph, so for us to be able to get a scientifically accurate number applicable to the star's actual distance from Earth, the units of that distance need to change. For example, if I measured the distance in centimeters, I'd find a scale to calculate what that number in centimeters would be in arc seconds. For reference, arc seconds are incredibly tiny, 1/3600th of a degree. This is because since we're viewing stars from so far away, the tiniest shift to us can be a really large distance in actuality. Fourth, find the stellar parallax. So far we've talked about parallax as the occurrence of a difference in where an object seems to be, but in this process we find stellar parallax, which is an angle. Look at this diagram. The apparent difference between the star's location is that overall angle, and the stellar parallax is half of that. Fifth, calculate distance. Do this by dividing 1 by stellar parallax. To understand why distance equals 1 over parallax, though, we need to do a little bit of trigonometry. As you can see on the diagram, we can make a right triangle using Earth's location, the Sun, and the star's location, where the distance from Earth to the star is a hypotenuse, and the Sun to the star and the Earth to the Sun 2 legs. On the right, you can see how if you take the tangent of the stellar parallax, you can end up with essentially distance equals 1 astronomical unit over parallax. And because of the definition of an astronomical unit, it simplifies down to distance equals 1 over parallax. This distance is in a unit called parsecs, which is around 3.26 light years. You might notice that all this calculation technically gives us the distance from the star to the Sun, not the Earth. But because the distance to the stars is usually incredibly large, the distance from the Earth to the Sun is negligible, and calculating the distance from the star to the Sun is the same as calculating its distance to Earth.
Feel free to calculate parallax whenever and wherever. With that being said, see you!